Let's look at the two-sum problem. So given an array of integers, numbers, and an integer target, so we want to return the indices of the two numbers such that they add up to the target. So here are some important constraints. So we assume that each input would have exactly one solution, and also we may not use the same element twice. So another one is we can return the answer in any order. So let's see some examples. For example, example 1. So the target is 9, the numbers given here. So from this one we can see the numbers 2 and 7 corresponding to index 0 and 1 adds up to 9. So we return a list that is 0 and 1. So for the second example, the target is 6. So we are going to return index 1 and 2 because in the 2 and 4 corresponding to these two indices adds up to 6. So similarly, for the example 3, we see the first two elements add up to 6, so we return 0, 1. So here are the constraints. So here we have the length, which can be up to an order 10 to the power 4th. And the next two constraints is about the element in the array. So an important one is we assume, again, there's only one valid answer. So for this problem, typically there are two types of solution. The first one is to use sort and then do two-pointer. So the second one is to using a dictionary to store the elements we have seen and check what we need to have in order to add up to the target. So here we would like to give a solution corresponding to the second line of ideas, and also we want to explain some of the extensions of this solution. So in order to fix the idea, let's look at one example. So let's see numbers equals 2, 11, 7, 15. So also the target is 9. So the idea is to use a dictionary, say M, to record the elements we have seen. Then we want to do the linear scan to see what we need to see in order to have a sum that is 9. For example, when we look at element 2, then we want to see 7, so which is 9 minus 2. If 7 is in the dictionary, if so, we have 2 and 7, which adds up to 9. So which is not, so we continue. So then when we look at element 11, so we want to check if 9 minus 11, which is negative 2, if this negative 2 is in the dictionary. If it is, so we have arrived at a result. Otherwise, we continue. So here is the does not, because in this after this step, the set or dictionary updates to 2, and after this step, the set or dictionary updates to 2 and 11. So now let's look at the third element, or the element corresponding to index 2, which is 7. We want to check if 9 minus 7, which is 2, if this 2 is inside the dictionary. Yes, so then we get our result. So we stop here. So in this demonstration, we are using a set, but the problem itself asks us to return the corresponding indices. So we just need to update this set to be a dictionary. So in other words, the demonstration can solve the problem that if there exists a pair of numbers that adds up to the target. So in order to return the corresponding indices, we just need to use a dictionary, right? So with this idea fixed, let's write the code. So first, we initialize the dictionary. So let's call this dictionary the thing. So let's update it as an empty dictionary. Then we do a linear scan or linear traversal. So because we need to return the index pair, so we will specify the index in the iteration. So for example, for I and num in enumerate num. So then we want to check if target minus this number inside the dictionary or set. So if it is, so we will return the index corresponding to the target minus sum num and the current index, which corresponding to the number num. So otherwise, so if it's not, so we need to we can write like this. So after this check, we want to update the thing. So we want to scan. So because we see current number, so we want to see its index is I. So with this specification, so we can actually stop here. The reason is that we assume there only one valid answer exists. So after this scan, we always we would have already returned a pair of indices. So let's check the result. So it passes. This problem actually is easy, but it's very useful. So if we look at some other problems, actually same idea applies. For example, we can check, we can regard it the following problems, say 523, 525, or 560 as extensions or variants of this to some problems. So which you can check the corresponding videos. Thank you very much. That's it.